Hey guys, welcome back to my channel. I'm still in Dallas. I've been hanging out with my friends. I just come back to home, but we're gonna play PlayStation and we're gonna hang out. But before we do anything, I want to solve one question. There was one question that I solved this morning, and I wanted to solve it and record it. It's about linked lists, and I actually have an interview this Wednesday and Thursday. There's actually 2 days left, which was I was in the third stage, so I'm expecting to get a good interview with that company because their first impression was very good, and I thought that if I solved the problems very well, I got a referral by the way from my previous internship as well. So I think that they're gonna hire me, but still, it was not very productive day because I came here to visit my friend and we've been hanging out. This is what it is. Let me show you the guys the problem and the solution. It's about the linked lists, and it's actually asking me where the two linked lists are intersecting. If they're not intersecting, I need to return null for the question. I decided to solve the question with a hash set first because I thought that if I put every point to my hash set and if it contains it, they needs to be that shows that they're intersecting. But there was a hint that I noticed here, like could you write a solution that runs in ON time and use only O1 memory, which showed me that it's not gonna be hash set because hash set is not gonna be O1 memory. I need to use a space basically. Okay, the way that I found it was first I can iterate over the whole linked list, the first one and the second one, and find the difference between the lengths. So let's say this is um, this one, its length is more than the other one node. So if I start iterating at the same time, after this one iterates one, for this one, the second iteration for the first one is going to be the first iteration. If they start at the same time, they're going to intersect at C1. But the better way to approach this problem was instead of iterating over the whole one linked list, whenever we start our iterations, if the shorter one comes to end, we can say that the next of this one is gonna be B1, and for this one that comes from the B1, their next is gonna be A1. Um, Basically, they are gonna intersect again at C1. Let me show you with this example at the bottom. So let's say we started with 3, 2, 4. After 3 iterations, it's going to be at the end of my, like after 2 iterations, it's going to be at the end of my second linked list. So I will say that the next of this one is going to be 1, and for this one, after 3 iterations, it's going to be here. And think of it, whenever it's at the 1, the other one will start from here. So I will move 1 and 2, and 1, 2 is going to be here at the top, the one that comes from the shorter, and the one comes from the shorter will go longer, will go to 3, and the next will be at the same point. It's a bit hard to explain. Let me show you guys with actually the code. Hopefully you can understand it. If you try it yourself, you will understand that it's working, so that you can easily find the intersecting point. You don't need to iterate over the whole linked list. I don't know if it's a better, if it is shorter than the other one because you're basically iterating over two linked lists again. But this approach seemed a bit smarter for me. So let me start with the base case. If had a is equal to null, or head B is equal to null. I just need to return null because there's no reason to check if they're gonna intersect. So here I will create two different variables for two different nodes for head A and head B. I don't want to make any modifications on head A and head B because it says here where is the constraints? This do not intersect, number of, okay, will be accepted, two heads, and solution. Okay, note that the linked list must retain their origin structure for the function return, so it's good to create this node for yourself. This node, I'll say hey A directly is gonna be equal to head A, and this node B is gonna be equal to head B, and there needs to be a while. You can put a as well. I don't know. I'll use while A is not equal to B, because whenever they are equal, that means they are intersecting. So we need to actually break the loop and go to the end of it's basically our solution. So we need to make our constraint like that. Let's put it here, this one, while A is not equal to B. So here is what we will need is A and B. We need to say if A is equal to null, what happens is I'm gonna put here curly brackets A dot next. No, actually not next. A needs to be head A, because if we say A dot next, it becomes a null pointer exception. A is equal to head A, no, head B. Whenever this one comes here like that, and then I say the next one is gonna be head B, so it will start from here again. Otherwise, what we need to say is else A dot next A is equal to A dot next. Okay, let's put this one here, and let's copy and paste, and it's gonna be the same for B. Instead, it's gonna be head A, no, B is equal to null. So eventually, after, if they intersect, they're gonna break the loop, and their intersection point is gonna be the same. So we can return A or B, it doesn't really matter. Let's return B here. But if not, let me check if it's running first, and I'll keep explaining. Okay, it's running. Well, let's submit it then. Okay, it's good. It's running. Let's submit it again, because this morning it was about 97%. Come on. Okay, 97. It's really up to the system. Anyway, here, whenever they're intersecting, we are returning it. If not, let's think of the condition where they never intersect. So eventually they are both gonna be equal to null, and then they are gonna still break the loop and come to this condition, because let's say they're not intersecting, B goes to N, we say, okay, B, start from A again, and B start over A and goes end of the linked list, so there's nothing to go because it's end of this one, so it's gonna be null, and the same for A and B, whatever. Eventually they're gonna be equal and they're gonna break this loop and work well. So this was a bit smarter approach, but that is a common question. Hopefully I explained it well. Thanks guys for watching. Hope you have a good day. Bye.